In this video, we're going to talk about Z-finish machining. Z-finish machining works by taking cross-sections along the Z-axis of the part at different intervals and then machining around the profile of those slices. To begin, we're going to move up to NC, down to 3-axis, and down to Z-finish. SURFCAM is asking us to select the cut surfaces, so I'm going to choose Visible up above, and then change our tool from a flat end mill to a ball nose end mill. We'll choose a 375 4-flute ball nose end mill to cut the part. Click OK, and the next thing I'll do is change the tool number, length offset, and diameter offset to 1, which will be appropriate for our machine. Next, we go to the Cut Control tab. The rapid plane of 4.5 is approximately an inch above the highest point of the surface, so I'll leave that alone. Right below that is Step Down. This is the most critical field in 3-axis Z-finish. This controls our step down from top to bottom along our Z-axis. I'm going to leave it at 0.1 for the moment and then leave the rest of this information alone. We'll come back to it later. I'm going to click OK at the bottom, and our tool path will be generated. If I zoom up on our Z-finish tool paths, you can see several important things. The first thing to look at is we get a consistent 100,000 step down on our orange surfaces. If we look at our purple colored surfaces or our cyan colored surface, that is the flatter surfaces, you can see the 100,000 step down gives us a wider spacing between passes. This is because Z-finish takes slices along the Z-axis. It works best on steeper surfaces. The other thing you can look at is as we go across the part here, when we come to an open contour, we're going to step up, wrap it back across, wrap it back down, and continue cutting in the same direction. On the orange surfaces, where we can go completely around the surface to cut it, we do so. I can make an adjustment to this tool path by going up to the Operations Manager, right mouse clicking on our 3-axis Z-finish pass, and then regenerating the tool path with original geometry. If I go to the Leads and Links tab, I can see that in the steep regions we've asked it to climb mill everything. I can change that to conventional, but if I want it to cut in both directions, I can change it to bidirectional. I'll click OK down at the bottom and we'll regenerate. When we look at the part, you can see that we've reduced the number of rapid moves by allowing the tool to cut back and forth across the part. Another thing we can do by going to the Operations Manager and regenerating again is to change the angle range that we're cutting. Here we're cutting from 0 degrees to 90 degrees. 0 degrees is a completely flat surface. 90 degrees is a vertical surface. If I don't want to cut some of the flatter surfaces, I can change my angle range. Here I'll change it to 60 degrees and click OK. If we look at our new tool path, you can see that by adjusting the angle range from 60 to 90 instead of 0 to 90, we have eliminated cutting on the cyan colored surface at the top and on the purple surfaces as well. One thing we have left though is a lot of rapid moves. We can make some adjustments to that will make the part cut a little bit faster. If I go to the Operations Manager and right mouse click on 3-axis Z-finish, regenerate tool path with original geometry, and go to the Leads and Links tab, we can change our retract strategy from full retract to shortest route. Click OK and OK again, and it will regenerate. When we look at the part with the shortest route retract strategy selected, you can see that the vertical rapid moves and horizontal rapid moves have been changed, and now the rapid moves follow the shortest distance from one starting point to another.